So wow, it just started recording. So this is a continuation of the nervous system. I'm hoping that you guys left off on the nervous system like a week ago. So with the nervous system, you have like an input, and then it gets processed, and then you have an output, right? So if you put your hand on something that's like cold, right, you have like sensory neurons coming up to your brain, and your brain, let's say it was hot, right? And then your brain sends something down to your muscles, and then you move your hand off, right? This is kind of similar idea, except that it's a chemical, right? So if you think about adrenaline, you've got two things going on with adrenaline. Let's say there was like something that you know, like a wasp nest dropped in the class, like a nest of hornets, right? So you're not really going to do a lot of processing. You're going to be out the door, right? So that's nerves. That's not actually adrenaline, because when a hornet's nest falls, I'm out that door. I'm not waiting 5 seconds or 4 seconds for adrenaline to start working. I'm gone, right? That's nervous system. I see something, I process it, I send nerves to my muscle, and I'm gone. But once I'm out in the hall, now my adrenaline starts kicking in, right? So if the hornets leave the classroom, now I'm starting to work on adrenaline, and I'm running down the hall, or I'll fight them. So hormones take a little bit longer, not a lot longer, we're talking seconds, right? But hormones take a little bit longer, but they stay around for a longer period of time. The nervous system works right away, but it drops off in a shorter period of time, right? So that's one function of hormones. Another is to regulate your body. Are you going into puberty? Are you trying to adjust your body sugar? So you're trying to keep homeostasis, right? That whole idea of keeping a balance. Homeostasis, you want to keep balance. When it's cold, you shiver. When it's hot, you sweat. That's trying to keep homeostasis. You're trying to keep your body at one point. I picked the wrong mouse. And so your body works on this idea of homeostasis. And whenever it can't keep in a homeostasis, it tries to do something called negative feedback. So if your blood sugar, for example, goes too high, what hormone makes your blood sugar go down? Like people that are diabetic, what's their issue? What's the hormone? You don't have to answer right now. Just think it to you. Yeah, insulin. They're not making it right. So blood sugar goes high. That's the problem. What's the solution? Insulin is released. And then insulin's not going to be released forever. Once your blood sugar gets back to normal, insulin stops. That's negative feedback. You're fixing a problem. Something negative stimulated your hormones. But the hormones aren't going to go forever. They're going to stop. What's the problem solved? That's negative feedback. So your body's working on that. There's also positive feedback, by the way. Well, I'm not going to write it. But positive feedback, there's not a lot of cases. Most of the time, your body uses negative feedback to keep this balance. right? But let's say you're having a baby. So your body's like, okay, there's a problem. We have this baby coming out. But you don't say like, oh, push it back in. That would be negative feedback. All right, shove it back in so the pain stops. No, it's like, well, it's coming out. Let's help. You know, it's going to happen. Let's just push the baby out. And so you start secreting more hormones, right? Whereas before you would secrete something like oxytocin or whatever. We'll get to all these. Now you're dumping other things. You know, you're dumping adrenaline, you're dumping estrogen, you're whatever, a bunch of hormones to get that baby out. So it's like positive feedback. It's like you're encouraging. Oh, that's the way. Positive feedback is encouraging feedback. Okay, yeah, you're having the baby. Let me help you. Keep it going. Let's get this done. Negative feedback is, no, how do we get this thing to stop? So your body's always going through homeostasis, and when it can't, it tries to adapt to a new situation. So you see like boxers, like they hit their hands against a wall or something like that. They're doing that because your body's adapting. Because you keep hitting your knuckles against the wall. So it's like, now this person's going to keep doing that. So I'm just going to put more calcium in the knuckles to adapt to it. So if you can't balance things out, then you're going to try to adapt to it. So the endocrine system uses this, right? And so if we look at the word endocrine, endo means inside, whereas exo means outside, right? So we have, for example, an endoskeleton. Our skeleton's inside, right? And so now we have the word crin. Crin means to secrete. So we're secreting stuff inside. In the blood, that's what it means. We're secreting things in the bloodstream and they're going somewhere else. So my brain makes a hormone and it's going to go end up down somewhere in my kidneys or somewhere. That's what endocrine means. An exocrine is like, for example, sweat. It's going through a duct. Is there an E on that? I don't remember. Yes? Is that crazy? I forget stupid things like that. Like I'll bust out these long words this semester, but I forget how to, I misspell stupid little things. Like I don't put an E on endocrine. So exocrine is going to use like a duct. And endocrine is going to use mainly bloodstream. So we're mostly going to talk about endocrine stuff. Sometimes these hormones, well, most of the time, they're what we call circulating. So, for example, I keep saying adrenaline. Adrenaline is actually epinephrine, or epi, right? So epi circulates. It's released down by your kidneys, and it circulates through your body, right? It's not staying next to your kidneys. It's going to your adrenal glands, right? So it's going different places. It's going down to your legs. It's going to your heart. It's circulating through your body, right? But sometimes hormones don't circulate, and we call them local. So they stay around the area. In fact, some cells will make a hormone that's only going to go a very short distance away. Like your brain will make a hormone that goes just right next door in the brain. So we'll call that paracrine. Para meaning nearby, right? So if you haven't taken MedTerm, you should take it, and if you're taking it, don't blow it off. Like, yes, you're gonna get an A, and yes, it's flashcards, right? But learn the words, because that's the trick to all of this. It's all knowing the words. If you know the language, you can BS your way through everything. And really super long words are the easiest words of all, because they're just short words, right? It's like raincoat. It's like, oh, I know what rain is, and I know what a coat is. I've never seen the word raincoat, but I can figure it out. It's not difficult. So it's like that. I always try to. So para means near, right? So its cells are secreting the hormone, and it's going nearby. But sometimes you can have cells that make a hormone that goes to the same cell, which is auto. Auto meaning like self. For example, autoimmune disease, right? Your body's attacking itself, its own cells. So here, it's like a cell makes a hormone, and the hormone goes to the same cell. Like the heart. The heart makes a hormone that slows the heart down. It doesn't make sense, because you'd be like, why doesn't the heart just slow down? Like, why does it got to make a hormone to make it slow down? Why doesn't it just do it? We don't know. You know what, as thick as your book is, we know very little about the body. That's the truth. And I don't mean me. I don't know anything, but I mean like the experts. We only know a little bit. It's crazy. So, hormones made by nearby cells, hormones made by the same cells. What are hormones made out of? Good question that he didn't ask. Well, I'm going to tell you anyway. Hormones are either water soluble or lipid soluble. So for lipid, when we say lipids, we're talking about things like oil, fat and oil, right? So some hormones hang out in your water, and some hormones hang out in your fat. By water, you're thinking mostly blood. Most of your fluids, water. I mean, most of your body is water-based. We're water-based, right? But we have fats in us. Some hormones hang out in the fats, and there's two main kinds: steroids and thyroid hormones. We'll get to those. Steroids are going to be like exactly what you're thinking. Like you're thinking of what steroids are. That is what steroids are, but there's other things too. So steroids often end with O-N-E. Testosterone, progesterone, estrogen. It's not really O-N-E, but the sex hormones, those are steroids. And then steroids like cortisol, hydrocortisone, things that we think of as steroids. So they're all steroids. We categorize them all. They're all made out of cholesterol. So we always hear that cholesterol is like related to heart disease and stuff, and that's true, depending on what kind it is. It's all true, but that doesn't mean you eliminate it from your diet, because we use it to make steroids. But anyway, and then thyroid hormones, thyroid regulates your metabolism. So we'll get to that, right? And then over here, these are mostly made from proteins. So I'm gonna put peptide. I'll leave it at that. I'll put protein, mean the same thing. Peptide hormones, they're hormones made out of proteins. Sometimes they're called amine hormones. Whatever, those all mean the same. Like when you see these words, when you see the word peptide in something, you're thinking protein. When you see the word amine in something, like amino, you're thinking protein. Right? Those are words that also mean protein. Proteins, if you don't recall, proteins are extremely, extremely diverse. There's 3 main types of molecules, 4 main types of molecules in your body. There's molecules of fat, which are lipids. There's molecules of carbohydrates. There's molecules of proteins, and there's molecules of nucleic acid. Nucleic acid like your DNA. So you have DNA, fat, sugar, protein. Those are the main 4 molecules. Everything in me is my hair, protein, skin, protein. My fat here, lipids. So proteins are extremely diverse. Proteins are the most diverse. Hair, fingernails, muscle, antibodies, hormones, hemoglobin, receptors. I can go on and on and on, right? So you'll hear the word protein over and over and over and over. It's just one of the types of molecules in our body. Don't think of proteins as meat or beans or muscle or just hair. It's way more than that, right? So you're going to see it a lot. So anyway, water, lipid, that's it. And there's differences in how they can travel. Water-soluble hormones, your blood is water. Your blood's made from water. And the hormones are water-soluble, so that works, right? These hormones can go into your bloodstream without any problem. Not with these hormones, though, because they're lipid-soluble, so they're made partly from lipids, right? And oil and water don't mix. So you can't mix lipids and water. So they have to, what they're going to do is they jump on top of a protein, a transport protein. This is an example of how we talk about proteins all the time. They jump on the back of a transport protein, and that's how they get through the blood. Sorry, I got my mask full. No, I'm not. So we have hormones in our body, but we have hormones that circulate through our body, but why is it that they only go to one place? For example, or a couple of places, right? So like, why doesn't testosterone go to my eyeball and make me grow hair in my eyeball? Right? Why does it go like under my arms? Like what is it like why is the target, right? So the target cells, why are the target cells wherever they are? Why don't you have prolactin, which like makes you produce milk? Why doesn't that go to your earlobe? And then your earlobe will make milk, right? It's because the mammary glands have the receptors. It's all about receptors. And if you were to guess what kind of molecule, remember we got those 4 molecules: carbohydrates, lipids, proteins, nucleic acids. If you were just to guess what kind of molecule a receptor is, you've got those 4 choices. Just take a wild guess. Protein. You don't know what it is, guess that it's a protein, and you'll be probably right. Or if you want to, this is more important for like my type of job, if you want to fake that you know something, just start talking about proteins. Oh, it's a type of protein specific to target cells. Ooh, I didn't say anything. But if you don't know the difference, right, you're like, oh, very intelligent answer. I didn't say anything, but it's enough to get people off your back. Got some teacher calling on you in the future, just say something about proteins. Probably enough to get them to look away from you. First rule as a student, never make eye contact with your teacher. Y'all online, so you're fine, but when you're in class, don't make eye contact. They might tell you, oh, make eye contact. Raise your hand. Don't do that. We just start picking you. Like, what if I ask another question and nobody says anything? I'm gonna go back to you. Oh, she knows, she says stuff, she raises her hand. And now it's you all the time. What if you want to text somebody? You can't do that now because my eyes are always on you because you're the person answering questions. Don't make eye contact. Don't raise your hand. Don't sit in the front, but don't sit in the back. That's not the place to be unnoticed. Sit on the sides of the room. Right in the side, in the middle, that's your sweet spot where no one's going to notice you. Don't think you're going to sit in the back. That's the place where all the cheaters sit and the degenerates, and our eyes are always in the back row. Go on the sides, never be noticed. Target cells have receptors. Now, as a cell, if there's like not a lot of hormone in the body, you could make more receptors. A cell has anywhere from like 2,000 to 10,000 receptors. So you've got a lot of play, right? And so you just think about, well, if there's not a lot of hormone in the body, I'll just make more receptors. So we call that upregulation. So when you don't have a lot of hormone, you just make more receptors so that you could be better at getting that hormone in. That's an example of adapting. And then the opposite could be true, right? If there's too much hormone, then make fewer receptors so that you don't have to get overwhelmed by the hormone. And you can guess what we would call that. Downregulate. Make fewer receptors. For example, the morning after pill, RU46, and whatever, that's what it does. It downregulates progesterone. So it takes the cells, the relative cells, and it takes the receptors, the protein receptors for progesterone, and it makes them a lot less. And so the progesterone is still in your body, but it doesn't attach onto the cells, and so you can't have the fertilized egg implant on the side. Anyway, the idea behind that is that you downregulate. I got one more thing I want to talk about before I let you guys go. And do you have any questions so far?
No, I don't have any questions right now. But I for sure have to go back and and listen to it.
It's a lot, and I'm following the book. Like, I'm talking about stuff that they talk about in the book. Right, so we haven't actually talked about any particular hormones yet. That's not going to that'll be next class, right? I'm not actually gonna, I'm just kind of introducing the idea, right? So we know that they're chemicals. Most of the time they get put into the blood. Here, this is where the hormone goes to, right? So if I were to say prolactin, you're hearing the word lactate, lactin, so you're thinking mammary glands. So that's the target cell. All right, let me go to the last thing I want to talk about. So, how do hormones work? And that was one. I have a video I already made on this. So that's the mode of action. Mode of action meaning how does it work? So what is it that hormones do exactly? Hormones change the behavior of a cell. Meaning that it makes a cell do something that it didn't do before. So you start doing something new, or stop doing something that you used to do. That's it. That's what changing the cell behavior is. Did it used to grow hair? Stop. Stop doing it. You didn't grow hair before? Okay, start now. That's what hormones do. Are you producing milk? It's time to stop. Make a hormone. Stop. Or if it's time, the baby's coming out, getting ready. Start making it. That's the motive. That's what hormones do. They make the cells change their behavior. How they do that depends on the hormone. So we're going to go back to our groups. Whether they are lipid soluble or water soluble, they have different ways to change the behavior of the cell. Lipid soluble is going to be genetic. So we're talking about DNA. So lipid soluble is the easier one. Lipid soluble enters the cell, the target cell, and it's going to, this might be too small for you guys to see, now I'm thinking that. It alters genetic expression, meaning that you have genes in your body that are going to do things, right? Genes make things happen. And you're turning these genes on or off. You're flipping the switch of your genes. So the membrane of a cell is made out of lipids. You know, it's not the wall, but like the wall. The membrane, we call it a membrane, it's made out of lipids. If you remember, phospholipid bilayer. So it's made of a phospholipid bilayer. I think I just solved my math problem. Maybe I did. So it's made of lipids. So this hormone's lipid. So it can go into the cell because the wall, the barrier of the cell is lipids. So it just goes through. It goes into the nucleus. It changes the DNA. When you alter the genes, then you get your cells to do new things. Change the behavior of the cell. That one's easy. So that's it, that's done. The water soluble is difficult. So before I start water soluble, I just want to go over again enzymes. It's like a general thing. It has nothing to do with the endocrine system solely. It's just like enzymes in general. What do they do? You should have learned this in biology 1, but you might have forgotten. Enzymes speed up reactions. Okay, that's officially what they are, or they'll be called like a catalyst. Like if you take the Hesse or the T's or something, they might call it a catalyst. Enzymes are catalysts, where they speed up reactions. But that's not. This is killing me. But in reality, enzymes make things happen. Because when we say that they speed up reactions, reactions meaning what? Reactions are pretty much two types. Either you're making something or you're breaking something down. Those are your reactions. That's reactions in your body. Making things, breaking things up. With the enzyme, something that would take like a couple of years would only take like a few minutes. And I always use the example of amylase. Amylase is this enzyme that we have in our spit, and it breaks up starch. Without the enzyme, it would take us 2 years to break up starch, like bread. With the enzyme, it just takes a few minutes. So you see like the difference. You're talking about a few minutes versus a couple of years. So really, when we're really saying it, the enzyme makes things happen. But technically, people will say, "Oh, well, no, the enzyme doesn't make it happen because it's gonna happen anyway," right? But really, it makes things happen. So if you stop an enzyme, you're stopping something. Or if you activate an enzyme, you're gonna make something new happen, right? And all the medicines, a lot of medicines are based on enzymes. So that's what enzymes are, and they're proteins, by the way, but that's what enzymes do. Enzymes make things happen. They make reactions happen. Right? Otherwise, it's not going to happen. Maybe it's something that will never actually get around until you're dead anyway. So with the enzyme, you make it happen in minutes. So water-soluble hormones are ultimately going to change the cell behavior by enzymes. Because if you can introduce an enzyme, then you get the cell to start doing something. Yeah, that's what it is. So lipid-soluble changes the behavior by changing the DNA, changing the genes. Water-soluble is going to activate enzymes. The enzymes are going to change the cell behavior. You see, there's like two different ways. Change the genes, lipid soluble, or change the enzymes, water soluble. I wish it was that easy, but it's a process. Here's my cell. I'm going to put my nucleus in the middle, not for any particular reason, but we always do that to show it's a cell. And in red, I'm going to put a little receptor here. Doesn't matter if you can't see it. But that's a receptor. That's how the hormone is going to, that's how these dots are the hormones. Why are they, that's how they know to get to the target cell. They're looking for that receptor, right? So the first step here, so this is water soluble. These hormones are water soluble, but this is a lipid. So the water can't go through the lipid. So these hormones, whatever they are, never actually go into the cell. So the hormone is going to activate a protein. Receptor, I should say. The hormone activates a receptor. So this is going to be like a chain reaction. A causes B, B causes C, C causes D. There's really no good way to learn it other than to memorize it. And it's got a lot of words. You're going to have to learn new words. So the hormone activates a receptor. Right on the other side of this receptor is another protein, right on the other side of the wall. So I'm putting like a, I don't know, whatever. We call this a G protein. So this receptor gets activated, and that triggers this protein right on the other side of the cell, like inside of the cell. So receptor activates G protein. Just the letter G. Inside the cell, you have this enzyme that's waiting to be activated. You've got it inside your cell right now. It's just not active, it's inactive. So the G protein is going to activate it. It's called adenylate, cyclase. ASE tells you it's an enzyme. The G protein is going to activate adenylate cyclase. I'm telling you this because it will come back in the future. Not in this class, I mean in other classes. So we've got this hormone activates receptor, G protein, adenylate cyclase. So I'm going like A to B, B to C, C like that, right? So adenylate cyclase is going to turn, now that it's activated, it's going to take this molecule ATP. So its job, this enzyme's job, is to take ATP and turn it into something called cyclic AMP, which we could just call CAMP, CAMP. I know that's messed up. But we're almost done. So, you have ATP in your cells right now. You have ATP all over your body, but it's in the cells. Once you have adenylate cyclase get activated in your cell, it will turn this ATP into this other chemical called CAMP, cyclic AMP. And cyclic AMP activates another set of enzymes called protein kinase. We're now done, just about. I got one more thing. So it's pretty much enzymes activating other enzymes, which turn around and activate other enzymes. And at the very end, and of course I got to end it with like a long word. Another stupid enzyme. Okay, I'll let you write this or not, and then I'll talk to you about it. But I'm done writing for today. This word phosphorylate, it's got the word like phosphorus, like so. Phosphorylate means to give energy to something. So these protein kinases give energy to other enzymes. What enzymes are these other enzymes? Depends on what you're going to do. Are you going to grow hair? Then the enzyme that grows hair. Are you going to make a hormone? Are you going to, whatever you're going to do? It's the enzyme that does that. So at the end of this whole process, we have these other enzymes. The enzymes are making your body change its behavior. So other enzyme depends on what it is your body's doing. But protein kinases are the ones that are going to give the energy to those other enzymes. But they're inactive right now in your body. They're not active. We have to activate it with CAM. We got to make CAM. We don't even have any. We got to make it out of ATP. And how do we do that? With adenylyl cyclase, which does not get active until the G protein activates it. G protein is not doing anything until the receptor gets triggered. The receptor's not going to get triggered until the hormone. So, yeah, it's a lot of stuff. How I approach these things is I write it out. And I know a lot of you, especially if you're younger, you hate reading and you hate writing, like with your hands. I get it. Just try it. It's a way to learn it. You just write it out, and then you walk away, and then you come back and try to write it again, and you're not going to have it all, and it's going to be spelled wrong and stuff, and then you look it up and fix it. Do it a few times, and you'll learn it. So this is how water-soluble hormones work. So that's a question. That's a test question. It's a big test question. It's a lot. It's the worst thing today that you're going to have to learn. And I don't do this like every single class. I give you just a paragraph of words. But sometimes, again, don't get thrown off and don't say like, oh, this is like, hell no, this is like every day. It's not every day. Right? This chapter is bad compared to other ones. So this is water soluble. Lipid was a lot easier. That was about changing genetic expression, right? The cell goes through the phospholipid bilayer, it goes into the DNA, it changes, it alters gene expression. So you're changing the behavior of the cell by changing the genes, changing the DNA. Here you're changing it by activating enzymes. That's a big question. Not multiple choice. There's not going to be multiple choice questions. So if I'm going to ask it, I'm just going to say, what's the mode of action of hormones? Pretend you're explaining to somebody how hormones work. I want you to be able to say it. That's your worst test question. That's your biggest part of a quiz. And probably put it on the exam too. So that's the big one. Right? But other things that I talked about, aside from mode of action, I'm going to erase this now because so let me just recap some things we talked about today. Talked about I don't know what we talked about. It's got this stuff in my head. Mode of action. We talked about types of hormones. Meaning like water soluble versus lipid, right? And for lipid, this is the easiest way to do it, like how I would do it. You know that lipid soluble hormones are steroids and thyroid hormones, right? And then for water soluble, you could just say everything else. You don't have to know peptide, whatever. Lipid soluble, steroids and thyroid hormones. Water soluble, the other hormones, whatever they are. It's good enough. Talked about, local versus circulating hormones. So you should, that's three, like one circulating, that's circulating in the blood, so you should know that. It just circulates through the bloodstream. Local is two types, autocrine, paracrine. Autocrine, same cell makes, the cell that makes the hormone, it works on the same cell. Paracrine, it works nearby. That'd be like another question. And then, so these three are pretty easy. Off-regulation versus down-regulation, why? Making more receptors, making fewer receptors. You should know why a cell does that. Okay? Up-regulation, more receptors, because you're making it more sensitive, right? Or however you want to word it, like in your words, because there's not enough hormone. That's a good answer. Because you want to increase the cell sensitivity. That sounds a little bit more sciencey. But essentially, you understand what's going on. Why would you downregulate if too much hormone? We want to decrease the sensitivity of the cell. I care that you understand it more than how you phrase it. If you're trying to figure out what combinations of words can I write down so that the instructor will give me credit, that's the wrong way to look at it. If I know you understand it, I don't care about the words you use. If you understand it, you won't forget it. If you memorize stupid words like phosphorylate, you're likely to forget it, right? There's a really good chance that by the end of the semester, you're going to forget adenylate cyclase, right? There's a good chance, I know that. But if you remember how the two types of hormones work, if you at least have an idea, and you can say, oh, the lipid-soluble or the water-soluble hormones, they suck. It's like this big chain reaction. But ultimately, at the end of whatever that crap was, some enzymes are going to get activated. Right? If you leave this semester knowing that part, then you'll be in good shape. It'll come back when you study pharmacology. This all comes back, right? And then this stuff, this stupid question that you memorized and you forgot, it'll start coming back into your head. So you'll feel relaxed, right? You're not feeling relaxed today, but in the future, you'll feel relaxed. So there's my quiz. 4 questions. So I'm telling you what's on it. I'm not giving you the exact wording of the question, but you know what I'm going to ask. Discuss the different types of hormones. Discuss local versus circulating. You just write, sentence, maybe a sentence, 1 or 2 sentences, short. And this one is going to be a bit long, right? And really the water-soluble part of this the lipid-soluble part is easier. It's the water soluble that's the worst part. But you know what I'm going to ask you, all you have to do is prepare it. And for those of you that really want to make sure you start the semester off with 100 and go really strong, write your questions out. Write it out today. The first day, write it out. Write your question, write your answers. Go over it. Write it. I mean, some of you, I guess you could type and you learn how to learn that way, but don't do nothing. Don't do nothing with your hands and think you're gonna like learn stuff. You have to make your fingers move, either by grabbing a pencil or by typing keys. You're gonna have to participate. So don't think you're gonna walk in on Wednesday or get online on Wednesday and just, it's not this type of class. Sociology, yeah. Use your common sense, remember a few words, you're good. You'll get at least a B, right? Not here. So you gotta work on it. All right, so I'm gonna stop recording. If any of you have questions, let me stop recording. You guys hang out for a second. Those of you in lab,